Hey guys, Paul, Inventor3 here. Uh, Today's the day of all days now. I'm going to open source this. Everything I've been working on for the last 3 years with this particular project, I'm going to give it all out today, right now. The whole thing. Secret sauce and everything. Wow, I don't even know. First, I'm going to show you original schematic when I had about 700 LEDs, and you can go back to this video series and check that video out when I had the record. It says in the title, wireless power transfer, WPT, 700 LEDs lit now. Anyhow, then I'm going to show you the original schematic. I'm going to show you the schematic that I'm using now. I'm going to explain everything, and then I'm going to go through and show you exactly everything I've got and explain it along the way. I'll talk about and show you a couple real quick setups, and then I'm going to talk about the asymmetrical capacitor and show you some stuff with that. Huh? Asymmetrical capacitor? All right, we'll be right back. All right, so let's see here. First, I'm going to show you. Oh, and guys, get a pen and a pad of paper right now. Take notes or questions you want to think about during this video. Do that now. Alright, here's the first original schematic I had when I had about 700 LEDs. I'm going to explain all this more in depth in a little while. But you can see my main source comes in here. And here's 3 strings of jumbo LEDs. Like I said, you can look back to that video. There's 80 LEDs, 80 jumbo LEDs, 80 jumbo LEDs. Or I should say 80 in series, 80 in series, 80 in series. That's a lot of voltage. That's a lot of energy. Alright, now all 3 of those chains, the negative end, and I've told you guys this a few times. Now these are only like 3mm LEDs because I didn't have any more jumbos. I should have went with the same thing. It would have made things a lot easier, I bet. Yeah, and here's a little. Okay, this is the main secret sauce there, guys, and I'm going to be going over that real soon. Alright, now down here, 468 LEDs. Yeah, what is that? 156, or I forgot how many in series. 156 in series, 156 in series. And it goes down to earth ground. Bridge rectifier. Now you see there's 3 little dotted circles I have here. Right at this point, I hung a wire down, and you can see in my videos, like I said, go back to that video. I forget what number it is, but look for the title. You guys can search for it yourself, no problem. Go to my channel. You hang a wire, and guys, listen, what I'm giving you today is a lot. This could be world changing. This a lot could be done with this, but it's going to take some time and a lot of experimenting. And there's a lot of guys out there who are better at electrical engineering than I am. I'm open sourcing this, so the one thing you could do for me, I've got no donation button or this and that, and yeah, anyhow, you could help me by sharing this video. Make this the one freaking video that you share. This is the video. Alright. So this one wire, I've lit bulbs off of that. I put a lot of power. There's a lot of energy at that point. Now you can see how at this point, I've talked about Dr. Stifler before, and you could say at this point, I never thought of myself as copying Stifler. That's why I've told you guys, there's the Mueller loop. And I said, well, the more I thought about it, I said, this is a loop. And there's one string going through the middle. And it's connected to another loop. This is a double loop, see? And these strings. Now the important thing about this setup, when you get this balance, believe me, the number of LEDs I had to have here had to be perfect. And sometimes I even add a length of wire off that center spot. When you get these two balanced just right, that's why I said I should have used the exact same LEDs here and here. It would have made things easier. But when you get things just balanced, first of all, these are all lit, and then all of a sudden I'll have all these, and then I'll connect all these at once to all these, and this group will not dim at all. Zero, zip, zilch. Negative end to a negative end, and everything's to ground. See if you can make sense of that. Where are the electrons and that coming from? I believe now, what was going on though is these are on when these are off, and these are on when these are off. That's why there's zero loss of energy. That would be my explanation. You could say I also had some small coils in here. I did not need them on all three. There's a lot of balancing on this. But anyhow, I just wanted to show you that. If you go to the other side, there was a little mistake here. You could pause the video. Correction. Was it the negative end of the first 10 LEDs? And each string is connected to positive end of next 10 LEDs in each string. You could read the rest here on the opposite side of the drawing. I have positive end of first LEDs and it's going to negative end of next 10 LEDs and back string. Each string, this was not drawn correctly. This is the correct drawing. You can see where I've got circle here. It's just one little connection or one little minus or plus that I had wrong or something. Like I said, in those areas. So anyhow, guys, okay, now let's keep moving on. That's the original schematic. This was the schematic I was telling everybody that if I die or something happens to me, to put that out on the internet. This is very important. I mean, right now, if you just utilize this in your own home, you could save more than 50% energy. That's for sure. A lot more than 50% energy. A lot more. Anyhow, this is the schematic I'm going to show you today that I've been working on a lot. Now you can see there's a loop. Again, when I got to this point, I never thought about, oh, I'm doing something like Stifler did, but I guess you could say I am. So here, let's take a look at this. 40 megahertz. Take a video screenshot or whatever you got to do, guys. Click, okay. DC cap, no diodes, and all LEDs bright. First one does not burn out. If AC, then use diodes. Alright, what I'm talking about, and this is the diodes, 1N4, 148, you want to use those diodes. Fast switching. Alright. I'm talking about this capacitor right here in the loop. If this is an AC capacitor, then you want to have like a diode right here. Okay, that's all. You want to put a diode in there. Otherwise, one of your LEDs gets a lot brighter than the other ones, and it could burn them out all the time. Or you use a DC cap, and there's no problems. Now, guys, yeah, you're gonna see this. Here's where my negative, this is what I never showed you guys. This is my secret sauce. I'll be showing you that in a minute. This is my wave. Now you can see how I got all these spikes in the corners. I believe that's very important. Okay. Negative, add different lengths of wire and scan frequency each time between 0 and 3 megahertz. Look for multiple frequencies. Use AV plugs. Alright guys, let's go through this here. There's my frequency generator. 12 volts. I'm at 2.390. That frequency really depends on what you have in your little loop-de-loop here. Your coil, how many LEDs, how much of a load here, even if you change your primary coil, and actually this other plate that I'll be showing you, if you raise that or lower that, that's going to change your frequency, all different things here. Okay, we come out here. Here's a little AV plug I use right here. You can see it's lit up right now. It just goes 2 diodes. That's it. See, I just stick it under this cord here, or lay it across it, or whatever you want. And when you see that light, and this is just nothing, this just hangs here, it's just acting like there's a little bit of a ground. Like that LED will get brighter if I touch it too, it should. Sure. That's right. But anyhow, that is a signal indicator too for me when my loop is in resonance and things start working, that will light up. Now, sometimes you have 2 resonant frequencies, so you got to keep scanning, make sure. It could resonate and things could light up and work at 2 different frequencies, but one is mainly always going to be better than the other. Alright, so let's go down the line here. I'm sorry. Here's our cord here. I got it taped down. It's actually back here. Okay. Here's where the positive and negative separate. Positive was the one end of this coil. There's that coil. Right there. There's everything on it. Okay. It's a 20 average AWG 20 gauge. 0.031 thousandths in diameter approximately. Alright, so the other end of that coil, yeah, we're going to follow the positive end first. Actually, here's the negative end right next to it. Here's the positive, here's the negative. There's the positive, positive. Alright, there's a lot of stuff and wires in the way here, guys, but this is it here. And here it is. I've always told you guys what I'm hiding from you is simple, but yet at the same time, it's really cool. Like I said, it was just something so that in case I've ever wanted to patent it later on, and I've had it online this whole time, I would probably still be able to do that because I did not show the whole system. Anyhow, alright, let's move that. This is my TX-RX. You can see my receiver. Those blocks of wood are just some spacers. Just have a piece of sheet metal over it. Let me show you this real quick. There was my schematic. There you go. So you got the transmitter is one plate. The receiver wraps all the way around the transmitter. Okay, so there's you're basically receiving 100% of your energy. Now this plate, this is your negative. Okay, that was the other wire that was over here. Now that comes down. That comes down. Oh, it's actually, that's why I said it's kind of messy here, but it comes around to the other side. And this is it here. It's actually not the same color as it was over there, but this is the same wire. I guarantee you it connects right there. If I touch this plate, it'll throw everything. The lights will dim. Oh, I got it pretty good right now. Anyhow, the distance of these plates is very important. Okay, I don't know what you would want to call this plate. Maybe it's a dampening plate, or I don't know, but it helps a lot. I don't know if this is what's helping in getting that square spikes on those square waves or not. I've showed you these LEDs down here. They're blinding right now, and they're just, you see, oh, I can't even see where I'm pointing the camera now. Hold on. Oh, no, I got my, hold on. I go up there, and I hope to God I'm filming this and you guys can see this. A bunch of diodes up here. They're just hanging underneath, stuck into that piece of styrofoam, just close to our plates. So from there, then, like I have on the schematic that I showed you, this white wire comes up, and that's it. Goes into our loop. So this coil here. Now this one is like 4 times. This should be about 10 megahertz. It's in a harmonic of our primary here, so I believe it's exactly 4 times the length of that. Okay, it's close to about 98 feet or something over. Okay, right, go loops around. It's this wire right here. Goes here. Another 10 jumbo LEDs that are blinding right now. Blinding bright. Comes over here. And then connects to one end of the capacitor. And then I got my meter probes on there, and this bulb is also in parallel coming off of that capacitor. It's across the capacitor. Okay, and the other end, actually, here's that little tiny, there's a diode in there, I believe, take my word for it. Going between the red and the white wire there, and just comes back around to the other end of our loop. And that's it. Right now, across that capacitor and that bulb, you can see there's 126 volts. Now let's see. Okay, so now I've showed you both schematics, talked about it. Let me show you now real quick. If I remove this bulb, let's see, yellow and the black one here, there we go. Now, these will not be as bright now. There goes the voltage now. It's rising up way beyond 120, 168. I'm gonna, let's see, we'll just change the frequency a little bit here now. Let's see if we can get that a little better or not. I could tell because those LEDs just got brighter. There you go, 180 something. 4, 5, 6. Now I'm just showing you guys quickly. If I get this tuned really good, I get 240 volts. Now that's with that capacitor. That's only 25 microfarads. Now we could also, let's instead, let me show you a couple LEDs here. I'm not going to light them all up, guys. They're not even all working right now. But I'm going to connect those right where this bulb was across here. Let's see, that's positive, and I got some long wires going across everything. Oh, geez, Paul, you've kind of, you dumb idiot. You idiot, Paul. You're supposed to discharge them first, Paul. You don't put 180 volts across 24. Oh my God. Oh man, let's see if this can even work over here now. Oh man, there. Oh, there. I fried my LEDs. I can't believe I just did that. Oh, almost did it again. Yeah, some of them are. Oh, yeah. But anyhow, guys, and these are diffused. They're not like super bright white, you know, blinding in your face, because they're diffused. And I can get them brighter. Now you got to retune. Oh, there you go. It's brighter right now. Now we're at 2.3 megahertz. You know, now these LEDs are blinding bright again, and these are pretty darn bright too. I was going to show you 400, but it's down to 300 now. Okay, let me see, what have I not said and wanted to talk. Oh, all right, now we're going to discuss this guy here and its importance, and whether it's important or not. All right, it's funny, guys, because all right, when I first started this project, yeah, we could talk about all those hybrid capacitors too and stuff. Oh man, what a nightmare. Anyhow, there you go. Here, this was my first original one. This plate, this was my transmitter receiver. There's another tab on the other side. This white one here is like a whole another one that I made. There's some plastic and LEDs on here, but we said, oh, let's make it smaller and less space. And at one point I said, let's make it bigger. There's one under here. It's almost 6 feet long, man. I've always had it hidden from you guys. Tape and foil under there somewhere. It's funny because all these videos, I would have my secret sauce right in front of your face. I would just have all my coils and everything right on top of here. Sometimes you could transmit and receive a coil that was sitting on top of the plates. There's so many different ways of doing this, guys. Alright, this plate is very important and how far and close it is. Even when I had this big long plate, I still had about a plate this big, not much bigger than that, at one end over here, and I just raised it, lowered it, moved it on and off. So that plate is very important for some reason. It helps really tune things in and helps a lot. Alright, let me show you this. Let me walk over to our board now. Let me show you this if I can get over to it. There's so much junk in here. I really gotta clean this laboratory out. Oh, I need a marker. Hang on. Alright, let's see, we're at 23 minutes already in this video. I'm trying to talk fast, trying to go through this as fast as I can. But like I said, this video is going to be as long as it needs to be. This is everything. I'm showing you everything. I remember at one point I showed you this, like in the 1800s, you had crystal radio sets, people picking it up. And if you, yeah, it doesn't matter if you had 100 people or 100,000 people. It doesn't drain the radio station, and I mean, it's not like a power station. And anyhow, you know, it's like, well, you know, what about all this energy in here? What about all this energy in here? It's all wasted. All this energy in between. All this energy from here and here. All this energy is just radiating. Wasted energy radiating, and it's not being picked up or used. So that's why that's why I came up with the design that I did, with one plate and the other plate around it. Now, there's a couple things to think about with that plate. Let's talk about the math real quick. Math. Yeah, well, I don't have to do the math. Let me just show you. Here's one plate. There's another capacitor plate, right? And now you say, oh, well, you know, I look up online, what happens if you have like an asymmetrical capacitor, right? What if that plate's bigger? And the best answer I could find is it would be the same as if they were the same size. Oh, it's not wiping off now. Oh, there it is. because they explain, like, say one's bigger here. Oh man, I can't draw right now. I got P too. Say, you know, that's why, because your energy's going between the plates, and anything over here is just wasted. It doesn't get collected. So they say if you have one plate that's bigger than the other plate, you could basically calculate it as being two equal plates, because the rest of the energy is being wasted. But now, like I have, what if you take this plate and circle around? Now, I could almost guarantee you're not going to find any math on that, okay? But what does that do? All right, so I just wanted to show you that and make you think about that. You could do it in spheres. There's different ways. You know, who knows? A sphere inside of a sphere. The other thing is, what I think about too with this, there's also the Biefeld-Brown effect. And let's see if I even have anything. Oh, there's a smashed one down there. One of my lifter crafts. There's some pieces over there. If you're familiar with the lifter crafts, ion, wind, and stuff. Yeah, there's different names for it. Anyhow, it talks about basically, right? Well, you got a small, skinny, sharp anode or something, or cathode. Doesn't matter either way. You could actually run them down to a bigger, wider skirt on the lifter craft. But it kind of makes me think about this, because you're going from one small one to a large one, and it's almost like this. You could think of that lifter craft too as a capacitor, okay, an asymmetrical capacitor. And then another thing I thought about recently too, I said, wait a minute, man, my Tesla hairpin circuit, that sucker, I said, that's the one where I grab each rod in my hand and it's safe electricity. And I have two hair-thin wires go up there and go across the room. Way over here where I'd have some halogen bulbs. You know, 150 to 150 watts. And they're lighting up. And the wire going to them is thinner than the filament, and it doesn't burn up. And that kind of makes me think of this loop too, because that is also a loop. It's safe electricity. You know, so what is going on, guys, in our circuit? Oh, my Tesla coils just this project has, in 3 years, is just taking over my laboratory. 3 tables here. I've never showed you this stuff. Plus a big pile of stuff over here that came from my shop when I had to sell my business for basically nothing, just to get out of debt from COVID. Anyhow, so that's it, guys. Wow, it was a half-hour video. It had to be as long as it did. I hope you guys took notes. I hope you know exactly what questions you want to ask me, because there's a million of them. Please, 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 again, share this video. I hope to God everyone replicates this. I want to see you guys working on this again. I know in the past, Dr. Stifler and, what was it, Lid Motor or somebody, I forget now, did a great job. And they even mentioned, yeah, it does need to be investigated more. Well, believe me, I've investigated the heck out of it, man. And I told you, this schematic here that I showed you, it's kind of faded already. That's really, this was something unusual too. I mean, just negative to negative. That don't make sense how many LEDs you have in series with each other. And, you know, I'm only getting, 12, 16 volts here. and per the manufacturer, at the most, this you could only draw 100 milliamps through this, and I really do expect that's when you have it up to 20 volts and more of a load. And it's now I've tried these plates, bigger, smaller. Let's talk about that for 1 second. It doesn't matter. I've got it to work. I'm just getting good at tuning this sucker too. I've got it to work with. I've even tried one that was only about that big, and I still got it to work. And I said, well, let's take it out. I still got it to work. Was it as good? Was it as bright? Was there as much energy? No. Could I have gotten as much if I played around with it for 2 or 3 days trying to tune everything in more? Maybe. I don't know. But I think this is important. Very easy tuning. This also is what keeps it as being an open circuit, because there is no physical connection except for some very thin. This one, my other ones had thick cardboard. This one's just got thin layer of plastic separating the foil. And believe me, I've tried it too with this big one. I've tried putting more foil in there, separating the plates more. Oh, we'll get more voltage, right? Higher capacitor. No, it didn't work. For some reason, I seem to be limited. I could turn this up to 20 volts. And the most I'll get out of this is about, 320 volts or something at the most. But there's a limit. And I keep asking myself, why? Why is it limited? No matter what capacitor I put on there, no matter what I do, I could only get about, if I have 12 volts applied, I could only get about 240 volts. No matter what kind of capacitor. It's why? Why am I getting from 12 to 240? Where's the transformation happening? Wherever it's happening, let's work on that and get it to transform more. That's what I'm saying. But I can't. It's like this puzzle. This is one question I could not answer all the 3 years. I cannot figure out what the control is. And these LEDs, they're really important. And I'm starting to think it's not the resistance. Well, it is too. I'm thinking it's got a lot to do with the spark gap. It's the spark gap. It's the number of spark gaps. It does make a difference too. If I have 10 here, this is the best. If I put 20, I won't get as much energy. I won't get 240 volts. I won't get that bulb as bright. If I only use 5 of these, I won't get it as bright. It's the best with 10. So I'm thinking it's about the spark gap too. And that's another thing I haven't been able to figure out to this day. To give you a frequency, I forget, what is the distance in plain English? What is the distance in between the anode and cathode and LED? Anyhow, guys, this is running along now. Geez, I've covered a lot here, and we'll just leave more questions and that. I'm expecting a lot of comments, a lot of questions. And I want to see a lot of people replicating it. That's the thing. I want to see ideas, guys, of how and what we could do with this and how we could boost things up greatly. It's funny, too. I started copying. The thing was, I was going with Don Smith. That's what I was trying to duplicate. And he had like 3 stages, and I got stuck on stage 1. I started lighting all these LEDs, and it's like, hey man, this thing, something's defying laws here, or seems to be. Alright guys, let's change the world together, man. Open source. Love you guys. Peace, love. And this is it. My workspace, man. I'm in this little corner. Too much stuff in here. Alright guys, till we talk again, please share, subscribe, like, and all that good stuff. Thank you.